Alright, welcome back to our 9.2 notes on area between two curves, or finding the area of a region. We're going to look at example 2. Example 2 now says a region lying between two intersecting graphs. So if you look back to the one that we did before this, you'll notice that those two did not intersect in the area that we were looking. That's why we had two vertical lines that gave us our lower and upper limit. This one says find the area of the region bounded by the graphs f of x equals 2 minus x squared and g of x equals x. Sketch the graph and shade the region. So first let's go ahead and let's sketch the graph. Okay, so all we really want to do first is graph these two functions. So we're going to graph f of x equals 2 minus x squared. So this tells us we have a quadratic opening downward. So the parent graph would start here at 0, 0 and go down, but we want to shift it up 2. So that means it's going to be here, 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 and then down here at -2, -2, and 2, -2. Guys, if you don't know that, you should be using your calculator to help you get these graphs, because you're going to need good graphs, especially when you're having to find the area or find the region that is being bounded. You need to have good graphs so you know exactly what pieces you're looking at. Okay, sorry, that side of my graph is not very good. Normally I rotate my paper, but kind of hard to rotate my paper while I'm on camera. Alright, so that's good enough. Alright, so my other function is just g of x equals x. So everybody should know that that is going to look like this. Okay, so I'm going to label these just so everybody sees. This is f of x. This one here is g of x. Okay, so it said to shade the region that's bounded by these two. So hopefully you can see that here they intersect and here they intersect. So that means everything between those two intersections is going to be the region that is bounded by them. Okay, so that is the area that we want to find on this problem. Okay, that means because these are nice pretty points, I know what my interval is. Okay, well, the x here is -2 and the x here is 1. Okay, so essentially I could have a vertical line here that's bounding it on the left, and I could have a vertical line here that's bounding it on the right. So similar to what we did before. Okay, except now we just use the intersection point. Okay, so now we need to figure out which function's the top. Hopefully you can clearly see that f of x is the top side of this, and the g of x is what's on the bottom. So in other words, as you look down from the top, which function do you come across first? You'll see that that's the f of x. And as you look up from the bottom, you're going to see which function do you run into first. It's going to be the g of x. So this one's going to be our top function. This one's going to be the bottom function. So we know that we're going to take the integral from -2 to 1. And I'm going to write this a little bit different. This is going to be f of x minus g of x. And that's going to be with respect to x. What I want to do on this problem, because it's fairly simple, is I want to show you something that's really nice in our calculator. Okay, so I know it's going to be a little bit hard to see on mine again, but if you go to where you put in your functions when you graph them, okay, I'm going to put the first function that we had, 2 minus x squared, in my y1 spot, and I'm going to put the x, which was the second one, in my y2 spot. Now you could graph this and you'll see where they intersect, but that's not what I'm concerned about here. Sorry about that. Okay, I'm just going to leave those in y1 and y2. I'm going to do math 9, just like we did before. We're going to go from -2 to 1, But this time, instead of actually typing in the functions, I'm going to make it a little bit easier on what I put in on my calculator. If you go to vars, then you arrow over to yvars, it's going to tell you function. And you want to go to function, so option 1, and you're going to do y1, so go ahead and hit enter, and we're going to subtract, do it again, vars, yvars, function, arrow down to y2. Now I see that I have my y1 function, which we typed it in, and that was our top function, and then our y2 function, we typed it in, and it was our bottom function. And we're going to take this with respect to x, and we're going to get that the answer is 4.5. So you can do that anytime, okay, just making sure you put the correct function for which one's the top and which one is the bottom. Okay, so let's go ahead and look at the next example. Let me get that up here. Example number 3. So this one, each one of these is a little bit different. This one is going to be finding a region lying between two intersecting graphs. Okay. It says find the area of one of the regions bounded by the graph f of x equals sine x and g of x equals cosine x. Sketch the graph and shade the regions. Okay. This point right here on the 1, that just means that there's going to be more than one region. Okay, it's going to intersect multiple times, and we just need to pick one of those. So we kind of get a little bit of options here. I'm going to go ahead and graph these. Hopefully we are very confident knowing what sine and cosine are. Okay, you're going to see on your paper this is 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. Likewise in the negative. So sine, sorry guys, sine goes through 0, 0. Okay, at pi over 2, it's up here at 1. Then it's back at 0. Then it's negative 1 and 0. It follows the same pattern on the other side. Okay, so this is our sine of x function. Okay, just giving it a nice little sketch here. Okay. Then I am going to sketch cosine. Okay, so remember cosine starts here at 1, and then it goes to 0, negative 1, 0, 1. On the left it's 0 and then negative 1. So we're going to get this function right here. Okay, hopefully you see that it definitely is intersecting more than in just two places. I am going to pick this area. Okay, you could pick this one over here. I'm going to do this because my x's I know are both going to be positive. So we need to find what this x value is here and what this x value is here to know those intersections. Now, guys, don't make it harder. I would put these into y1 and y2. So let's say we put this into y1 and this one into y2 in our calculator. Then we're going to graph it and use the intersection, okay, to find these intersection points. When we find this one, we're going to get that this is 0.785. Okay, if you want to use, in terms of pi, you can. I'm just going to use the decimals here. This is 3.927. Okay. Now all we need to know is which function is the top function. So I'm going to go back and I'm going to label. Remember the one that went through 0, 0? This one right here. This was our f of x, okay, our sine function. Then this one down here was our g of x, which was our cosine function. So my y1 happens to be the top function, and my g of x, which we have as y2 in our calculator already, ends up being the bottom function. So if you want to go back and use that y1 minus y2 in the calculator, it really kind of helps. So we're going to do the integral. Our x's that we said we were bounding is that 0.785 and the 3.927. So 0.785, 3.927. Okay, and we can either do it f of x minus g of x, all with respect to x, and you can actually type those in, or if you put that as y1 and this one as y2, you can just type in the y1 minus y2 like I showed you on the last example. This is going to give us 2.828. Okay, so that is the area. Now, if we found the area of this one, it would give us the exact same thing. So if you wanted to find the area of this other piece, that would be just fine. Either way, we should be getting the exact same thing. All right, let's look at example 4. Okay, example 4, we have curves that intersect at more than 2 points. Okay, so this one says find the area of the regions, see that plural here, bounded by the graphs f of x equals 3x cubed minus x squared minus 10x and g of x equals negative x squared plus 2x. Sketch the graphs and shade the regions. Okay, so when we sketch the graphs, again guys, plug them into your calculator. I would go ahead and say, let's plug this in and call it y1. Plug this one into y2. We're going to get those graphs. So I will do the y1. So the f of x function goes through 0, 0, goes through negative 1, 6, and it goes through negative 2, negative 8. Then it goes through 1, negative 8, and 2, 0, and then goes up forever. So I'm going to see this should be a cubic function because we had x cubed. So it's going to look like this. Go down forever, then it's going to curve and go back up forever. So this here is going to be our f of x function. Okay, now we're going to sketch our g of x function. This one should be a quadratic. It should be opening down. Okay, we are going to get that the vertex is at 1, 1 on this. Then it goes through 0, 0. Then it goes through negative 1, negative 3. Then it goes through negative 2, negative 8, which is right here, so that's kind of nice to see. On the other side, it's going to go through 2, 0. It's going to go through 3, negative 3, and 4, negative 8. So we should see that nice quadratic right here with the symmetry. Okay. Just getting myself a good sketch. Okay, this one we said is g of x. Okay, or in our calculator, it's going to be y2. Okay, so hopefully now what you're seeing is we've got this piece and we got this piece. So we have two regions here that we need to find. So I'm just going to call this one area 1. Let's call this one area 2. Because on this one, our top function is the f of x, but our bottom function is the g of x. So for area 1, we're actually doing the x of negative 2 to the x of 0. Our top function, which we said was f of x on this one, so that's our y1 minus our y2. With respect to dx, this is going to give us a 12. When we find area 2, this one is going to be from 0 to 2, except this one's backwards. Now our top function is our y2, and our bottom function is our y1. So making sure that we change that in our calculator, this one is going to give us a 12. So then we need to take these and add them up, and we're going to get an area of 24 on that one.